Welcome to a discussion of total petroleum hydrocarbons, often abbreviated TPH. Alright, let me walk you through the TPH subtraction option for compound math. There is another section which discusses compound math in detail, but in this application it subtracts the ISTD or the surrogate response from this TPH target compound response. Note that the ISTD or surrogate compound must have the same signal type as the TPH compound, and also, which makes sense because the purpose here is to subtract the contribution of this ISTD or surrogate from the target, that the start and end points of the ISTD or surrogate peak are within the RT integration range of the target. If we're using a mass spec here, we're expecting TIC responses. And also, let me point out that the corrected responses are in the response column, where the original responses are in the area column, so you can see the difference by comparing. This corollary here is that if the start and end integration points of the ISTD or surrogate peak are not within that integration range of the target, then no subtraction is done, and the area column and the response column will be the same. Some other setup requirements here, and I will go through that in the demo. The TPH target compound is expected to use the spectrum summation integrator, and we do have the ability to set absolute times for the peak start and end using that integrator. Also, the TPH compound, if it's a mass spec signal, the target compound needs to be set up as a TIC signal. And last point, this implementation of compound math adjusts the responses of the calibration curve. That is an improvement from the previous implementation, which used the TPH add-in. Let me walk you through the demo now. I'm going to show you GC only data, which is typical for TPH analysis. You can also do it with mass spec. As pointed out, the ISTD or surrogate peaks will be subtracted are the TIC responses. Alright, so for the demo I'm going to show you compound math, and from the compound math column I can choose TPH subtraction. Let's talk about the spectrum summation and setting the baseline. This is the spectrum summation integrator choice, and notice several choices here for setting the baseline. Lowest point, fixed baseline offset, and also added in this release is the ability to use the lowest point in a retention time range as the baseline offset. Now that allows you the ability to pick the noise level before the injection's elution profile as setting the baseline for that run. So here is where you set the peak end and start that will aggregate all that signal from start to end. So here I am for the demo in the method editor, and I've got the TPH compound and I've got the contribution of the surrogate. Note that the TPH compound has been designated with compound math set at the TPH subtraction. Also note that the TPH compound uses the spectrum summation integrator, and that has been set to use the lowest point and use these absolute times. All right, let's apply this method and get back to batch at a glance. And I can see here's my TPH signal, my adjusted calibration curve, and I can see that if I look closely at the area, I can see that the response has been corrected by the contribution of the surrogate. Let me put a plug in here for compounds at a glance. You can see here I've got the TPH area, and I've overlaid the compound of the surrogate, and you can see that's the integration of the surrogate correction. A good visualization, I suggest it might be useful. Thanks for your attention.